Ladies and gentlemen, this just in. 3AI Atlas has changed its trajectory. It's no longer drifting, it's moving toward Earth. We have confirmation that a massive burst of red energy from the Atlas object just struck Saturn's...
Things are reaching a critical point as 3I Atlas makes its daring descent toward the Sun. The timing could not be more striking. The solar maximum, the period when our star is most active, is now in full force. Solar flares, magnetic turbulence, and vast eruptions of plasma have made the Sun more volatile than it has been in over a decade. In this segment, we'll trace the dramatic developments of recent days, from the comet's tail abruptly changing direction to astonishing new imagery showing a jet of material streaming directly toward the Sun. For the first time, 3I Atlas has also appeared in solar coronagraph footage, marking a major milestone in its journey through our solar system. Meanwhile, spacecraft across the inner system, ESA's Hera, JUICE, and even NASA's Europa Clipper, are preparing for possible encounters with the comet's tail. And behind the scenes, the International Asteroid Warning Network, IAWN, supported by NASA, has quietly opened an investigation into the comet's unusual and rapidly evolving behavior. All of these updates come from direct observations, peer-reviewed research and mission data, not speculation or sensationalism. What's unfolding right now is simply the remarkable reality of our dynamic solar system. 3I Atlas is now on its final approach to perihelion, its closest point to the Sun, expected on October 29th. What makes this moment extraordinary is its timing. This interstellar object has arrived just as the Sun reaches the height of its activity cycle. The Sun's magnetic field is reversing, sunspots are multiplying, and solar eruptions are bursting from its surface with renewed intensity. For most comets, this environment would be treacherous. But for an interstellar traveler untouched by our Sun's heat until now, this is an unprecedented natural experiment. How will it react? We're about to find out, and the spectacle has already begun. Recent images reveal powerful jets of ice and dust streaming away from the comet's surface. Early observations have uncovered a rare and beautiful feature, an anti-tail, a stream of material appearing to point toward the Sun instead of away from it. While such structures have been observed before, most, famously in comet Kohoutek 1974, seeing it form in real time on an object from beyond our solar system is extraordinary. As the comet drifted out of view, scientists noticed its anti-tail gradually transformed into a more conventional tail by September. Spectroscopic analyses indicate that carbon dioxide is the primary force driving its outgassing. The delayed appearance of the tail may be due to larger, heavier dust grains being released, particles that move sluggishly, taking longer to be pushed outward by sunlight. Then something even more intriguing appeared in the data. Independent observers noticed faint but consistent movement near the edge of NASA's SOHO coronagraph imagery. Amateur astronomer Warwick Shapboom-Platt was among the first to detect the anomaly, and soon after, analyst Stephen Burns, renowned for his precision with solar imagery, reviewed a full week of data. His findings confirmed it. The object matched the predicted trajectory of 3I Atlas, and it was getting closer. In the coronagraph footage, 3I Atlas appears as a faint point of light drifting in retrograde motion, moving opposite to the background stars, exactly where astronomers predicted the interstellar comet should be. There's been no official confirmation yet from NASA or ESA, but if verified, this would represent a historic first. An interstellar object captured in solar coronagraph imagery, a rare, almost surreal glimpse of an alien comet skimming the radiant edge of our Sun. Yet the story grows even more extraordinary. 3I Atlas has now been photographed blasting a jet of gas and dust directly toward the Sun. Using a 2-meter twin telescope at the Tata Institute's observatory, astronomers captured 159 separate 50-second exposures, revealing a fan-shaped plume of material erupting from the comet's nucleus in the Sun's direction. The jet extends nearly 10,000 kilometers from the surface, evidence that the comet is behaving exactly as a volatile, ice-rich body should under such extreme conditions, and still, not everything is behaving as expected. Earlier this week, the NASA-backed International Asteroid Warning Network, IAWN, launched what it described as an emergency planetary defense exercise, after 3I Atlas began exhibiting unusual behavior. Operating under the United Nations Office for Outer Space Affairs, IARBN has initiated a global tracking and response campaign, its first ever coordinated effort focused on an interstellar object. Officials have emphasized that this is not a cause for alarm, but a simulation designed to test Earth's readiness for potential future celestial threats. At the same time, two of the most advanced spacecraft ever launched, ESA's Hera and NASA's Europa Clipper, are aligning for an unprecedented opportunity. According to new orbital modeling, both spacecraft may soon pass through or near the ion tail of 3I Atlas as it approaches perihelion. Hera's encounter window extends from October 25th to November 1st, while Europa Clipper's falls between October 30th and November 6th. If either mission succeeds in sampling the comet's tail, detecting charged particles, magnetic fluctuations, or unusual heavy ions rarely found in solar system comets, it would mark the first time. Humanity has directly measured material from another star. System.ESA has also confirmed that its JUICE, Jupiter icy moons. Explorer spacecraft will aim its instruments toward 3I Atlas between November 2nd and 25th, precisely when the comet is expected to be most active. However, there's a challenge. JUICE is currently using its high-gain antenna as a heat shield to protect against intense solar radiation. This means data can only be transmitted back to Earth through a smaller secondary antenna, resulting in slower communication. As a result, the first processed findings from these observations won't reach Earth until early 2026. Each of these missions adds a vital piece to our understanding of the cosmos. They remind us that the universe remains an unfathomable frontier, one we can observe and explore but never fully conquer. Yet through technology and imagination, humanity continues to reach further. But while humanity explores the stars through fiction, the cosmos continues to surprise us in reality. Astrophysicist Avi Loeb recently cautioned that the global scientific community should remain alert and develop contingency plans in case 3I Atlas turns out to be what he calls a black swan event, a rare, high-impact occurrence that defies prediction. The most puzzling aspect of this object is that its trajectory lies in the plane of the planets, and it's coming pretty close to 3 planets, Mars, Venus, and Jupiter, and that suggests maybe it has some purpose. Now, it doesn't necessarily mean that the object itself would deviate from its path. It could also release some smaller objects that would use this maneuver close to the Sun. We just need to monitor and see if there is some unusual activity either around the object or coming toward the planets. You know, there are orbiters around Mars. We are monitoring the sky around Earth with 3 observatories of the Galileo project. And I asked my research team to check for any unusual activity. Gladly, yesterday we had an announcement by the International Asteroid Warning Network that will establish a campaign coordinating observations from all around the globe, trying to get as much data as possible about the motion of this object. Because as it gets close to the Sun, actually a week from now, on October 29th, it will be at a distance of 203 million kilometers from the Sun. That is the best point to have a maneuver. To use an engine that would either give a thrust to the object in the direction of its motion, in which case it will gain kinetic energy, or do the reverse, in which case the object would brake and perhaps even release some mini probes toward the planets if it's technological. So we would like to know as much as possible about its future path, about the nature of the material coming out of it. It's the beauty of doing science, but in hindsight, it seems inevitable. In Loeb's view, the comet might appear natural, yet still conceal something unexpected, a kind of Trojan horse that challenges our understanding of interstellar visitors. Every new observation of 3I Atlas has revealed something that doesn't quite fit the cosmic rulebook. When researchers analyzed its spectral data, they discovered that nickel is more abundant than iron, an unprecedented ratio never observed in any comet before. Even the previous interstellar traveler, 2I Borisov, displayed a more typical composition. Now, a new study, published in the Astrophysical Journal Letters, has revealed yet another mystery. 3I Atlas is venting massive quantities of water vapor into space, even though it's still 3 times farther from the Sun than Earth. At that distance, An ordinary comet would remain a frozen, silent block of ice. This one seems alive, erupting like a cosmic geyser. Using NASA's Neil Gehrels Swift Observatory, scientists searched for the faint ultraviolet signature that indicates water release. Since direct detection of water vapor is difficult, they tracked hydroxyl gas, OH, a byproduct formed when sunlight breaks apart water molecules. The results were unmistakable. 3I Atlas was shedding water long before it should have been warm enough to do so. How much water exactly? Approximately 40 kilos per second, the equivalent of a high-pressure fire hose spraying continuously into space. From that rate, scientists estimate that roughly 8% of the comet's surface is actively releasing material, far higher than the 3 to 5% activity typically seen in comets from our own solar system. These findings reinforce a growing realization. 3I Atlas is not just another icy wanderer. It's behaving in ways that defy precedent, and each new observation seems to deepen the mystery of where it came from and what it truly is. So what's driving this unusual surge of activity so far from the Sun? Under normal circumstances, water ice on a comet only begins to sublimate, turn directly into vapor, once it nears the Sun and temperatures rise dramatically. But 3I Atlas appears to be following a different set of rules. Near-infrared data from both Gemini South and NASA's Infrared Telescope facility revealed that its coma, the hazy cloud surrounding its nucleus, is filled with tiny ice grains and frozen clumps of material drifting freely around the comet. Once these miniature fragments are exposed to sunlight, they heat rapidly and release vapor on their own, creating countless micro-outbursts. Think of them as floating geysers, each venting water independently, even while the main body of the comet remains too cold to sublimate directly. This could explain why 3I Atlas appears so active from such a great distance. It's not a single frozen core, but a swarm of icy fragments, each contributing to the comet's dramatic outpouring of gas and dust. And it's worth remembering, every interstellar comet we've ever observed has defied scientific expectations. Oumuamua showed no detectable traces of ice at all. 2I Borisov was rich in carbon monoxide, behaving more like a volatile rich object from the outer reaches of a cold star system. And now, 3I Atlas, against all logic, is venting water vapor in a region of space where no ordinary comet should be active. Adding to the intrigue, new observations from the James Webb Space Telescope have revealed an unusual chemical ratio in 3I Atlas's composition. The interstellar traveler appears to contain significantly more carbon dioxide than water, suggesting it may have originated in a colder, carbon-dense stellar environment very different from our own solar neighborhood. Every new detail brings us closer to understanding the nature of these rare visitors. And yet every answer seems to spark even deeper questions about what's truly out there among the stars. If you've enjoyed exploring this with us, don't forget to like this video and subscribe for more discoveries that redefine how we see the cosmos.